So let's talk about static equilibrium now. I have a very interesting question with me here, which is saying a uniform bar of length L and weight W, which is W1, to be equal to 35 Newton, is suspended at its end as shown below. A block of W2, which is equal to 10 Newton, is placed at 1/4 distance from the right hand side end. What are the magnitude of the force N1 and N2 exerted on the bar? Static equilibrium, when we're talking about this topic, we need to understand one thing. When we're talking about static equilibrium, we're talking about an object which is balanced. There are three principles which you need to be familiar with under static equilibrium. The summation of all the forces in x direction is 0. The summation of all the forces in y direction is also 0. The summation of torque is also 0. Now the challenge comes in to know where you are supposed to use this. Torque is the force times distance. Okay. Now, what we need to understand here is that there are some questions which will require us to use all the three conditions for us to to solve the question. Some they are just we are required to use only the first and the second one. Then other questions you are only required to use the third one only. But how can you know that this question I'm supposed to use the first conditions alone? In a case where you have been given angles only and you have got no distance, since we know that torque is equal to force times distance, there is no distance. You have only been given the angles, and they are trying to ask you to find maybe the forces. You can only use these two. You only use these. So you only use these if you have been given a problem only involving angles. There is no distance. If you have been given a question which only it doesn't have angles but it only has the distance, you use only torque. Only torque can give you the condition. Only torque can give you the answers you are looking for. So this is when you have been given distance only. There are some problems where you are going to be given both distance and the angle. You use all the three conditions. You use this and that. Now, from the question which we have here, we can clearly see that we don't have any angle. We are only dealing with a distance. Therefore, only torque is enough for me to get what I want. Okay? So what I'm going to do now is I'm going to say I'll use torque only. So we know that I'm going to get one of these as my pivot. So let me start with this. I'm going to get where there's n1 as my pivot. When I get n1 as my pivot, what should we know? What we should know is that the torque at that point is going to be 0 for n1, meaning I'm not going to consider n1 for that. Okay? Now, we know that the forces which are going downward here, W1, which is 35, W2, which is 10. If I add these two forces, 35 plus 10 is going to give me 45 newtons. Meaning that the force N1, when I add N1 plus N2, because we're talking about static equilibrium, this object should not move. When I add these two, I'm supposed to get as well 45 newtons. What does it mean? When I just find one N, I can also find the other N because I know that the total is 45. So if I get this one as my pivot here, meaning I'm remaining with this N2 here, which is going to be pushing this beam in this direction. Okay, then let's call this, since it's n1, I'll call it torque 2. This is this is going to be pushing this in this direction. At the same time, this will also be pushing it in that direction to make it balance. So I'll call this torque 1. I'll call this, okay, let me call this torque 2. Then let me call that torque 3. So we have clockwise. When you are going in this direction, is clockwise. When you're going in this direction, is anti-clockwise. So the rule of this is clockwise should be equal to anti-clockwise. I'll say clockwise should be equal to anti-clockwise. Now clockwise, how many forces do we have? We have got how many torque do we have? We've got torque 1. They are moving the same direction. Torque 2 should be equal to, and clockwise I only have torque 3. Torque, in this case, torque is the force, which is going to be, the force is W1 times the distance. Okay, then this one is going to be plus this, let me call it distance 1 as well. This one is going to be W2 times distance 2 is equal to, my force here is N2 times the distance, which I don't know. I'll just call it 3. So what we should know now is that the distance from this point here all the way to that point, we have been told that is L. I'll put L. Meaning for T3 here, I'm going to replace D3 with L. The distance from this point here to half, this is half here, is 1 over 2L. Then again, there's another distance from this point all the way to that point here. I can clearly see that it is in between W2 and the N2, which is going to be, we have been told that W2 of 10 Newton is placed 1/4. 1/4 is 1 over 4. So 1/4, meaning from this point to that point is 1/4. Meaning again from that point to that point is 1/4. So I can say half plus 1/4. Okay, which is going to be, here I'm going to have 4. 2 there is going to be 2. Here 1, 3 over 4. Okay, so here I'm going to have W1, I have it already. It's going to be what? So here I'll have 3 over 4L. W1 is 35. D1 now, in this case, D1 from this point is going to be half L times half L, like that. Plus. Then I have this one now. This is going to be is 10 times, I have 3 divided by 4, then L, like that. Okay, this should be equal to N2. D3 is the distance from Toku, from this point here all the way to that point, which is L. At this point, I can clearly see that L appears everywhere. I can cancel L. So I'll have 35 divided by 2. I'll have 17.5 plus 10 times 13 or times 3 divided by 4. I'll have 7 point what? I'll have 7.5, like that. I'll have 7.5 is equal to N2. So if I add those two, 7.5 plus 17.5, I'm getting 25 as my N2. Now we said that the total should be 45, meaning that N1 plus N2 is equal to 45. So N1 I don't know, N2 is 25, is equal to 45. If I shift 25 to the other side, to be 45 minus 25. So N2 or N1, sorry, N1 will be equal to 45 minus 25, which is 20. You can either use what I have used here, or you can also come back and plug in the values here. You use the same torque to come up with the values. So my N2, sorry, is 25 degrees, 25 newtons. Again, If I get this one as my pivot, meaning n2 is not going to be considered. Now I want to find n1. You can either use that method which I've just used there, or I'm going to use another method. If you want, you can follow the one I'm going to use right now. So if this is my pivot, this is going to be pushing this guy in that direction. Then these two are going to be pushing it in this direction now. So now I have also clockwise is equal to anti-clockwise. So clockwise, I have what? I'm going to call this torque 1, torque 2, torque 3. I have torque 3 should be equal to anti-clockwise. I have torque 1 plus torque 2. So torque is force times distance. In this case, torque 3 is n1. Okay, the distance, let me just put d. Okay, I'll put d. Now that distance is L in short. It's the distance from this point all the way to that point, which is L. Should be equal to T1 is W1 times the distance now for this is still half to that point, 1 over 2L plus. For T2 now is from this point to that point, which is 1 over 4. So it will be W2 times 1 over 4 then times L. So let's plug in the value. N1 we don't know, times L. W1 is 35. 35 times 1 over 2, then this, plus W2 is 10. 10 times 1 over 4L. I can cancel L. So I have N1 to be equal to 35 divided by 2, which is 17.5, plus 10 divided by 4, 2.5. So N1 will be equal to 17.5 plus 2.5 is 20 newtons. As you can see, using that one and this one, I'm able to get the same answer. So that is it for this question.